All right, next up is Domagoj Korais. Domagoj, household name too. He's going to tell us about Pandera, statistical data validation for Pandas. If you want to make your data processing more readable or robust, and even in production critical paths, Pandera can help you out. So Domagoj, take it.
Hello, guys. Let me share my screen. So can you see my notebook?
Yes.
Cool. So why we should care about data validation? As we know, those days, those data pipelines are quite complex. They can be managed by multiple teams inside of a company, and data can be transformed in many ways. So we can have some team generating some data, somebody else doing some data analysis, machine learning, whatever, and another one serving the results through a browser, through an app, whatever. And so we want to gain some control on how those data looks like. So we can abstract the concept of data validation with this simple function. We have a schema that applies a validation function v to some data x. If the validation function pass, then it returns the data themselves. If it doesn't, it returns an error. This means that the data x are how they should be, how we want them to be. Pandera implements this function s using three main components: schemas, checks, and schemas elements, that is columns. We can
just
see
get
a
bit
simple
of
example.
zoom?
Yeah, sorry. Sure.
Yeah.
Oops,
Thanks.
this is a... Wait. Okay, can you see now? Perfect.
Nice, better.
Okay, cool. So let's dive into some code. Here we have a very simple data frame. This data frame will have three columns, two of numeric type and another with some values. We define a schema for this same data frame, where we can define some properties that this data frame should have. So for example, for column 1, we say the type of the column, it will be an int, and we apply some checks on the same column. So each value needs to be less than 10. The same with column 2, and for column 3, we can apply some rules on the strings and check that they are with value underscore. Then we take the data set, we apply the schema, and we will have a validated data set. So what happens if we change something? Okay, we can change one column from the schema and we rename it. So column 1 becomes column 1A. Now we can again validate, and we check if the dataset df is properly defined. What happens? We have a nice error that says, oh, guess what? Column 1A is not present, but we are requiring column 1A because we added this to the schema. And this alone can be very, very useful if your data pipelines are complex and stuff are added on the fly all the time. So you can control the objects that you're passing around. Again, what happens if for one column I change the type? I can do that. I can check that, again, that the data frame has a valid schema. And what happens, I have a nice informative error. Column 1 should have a type int 32, but it has int 64. So again, this can be very useful if there is some casting happening under the hood, or if you are creating some data, so that you really get some control. So we talked about statistical checks, and this is another nice property. I'm sure that Roman will like it. We can do some hypothesis testing on the property of our data. So here we define a simple data frame. We have one column that has a gamma distribution, a second column that has data distributed normally. And we can see that clearly X1, the blue one, is not a normal curve, right? So we can define a test using a normal test, and with a given probability that the data contained in the column x2 are normally distributed. We again validate, and if we validate x2, that I remember was defined as a normal distribution, the schema validation will pass. If we try on x1 that follows the gamma distribution, it will not. Unfortunately, in this case, the error is not so explicative, but still it will fail. So we can add this even to data generated on the fly, scraped or whatever. Another nice feature is that you can infer a schema from a data frame, so we don't need to write them all the time. And this is an example of a schema. We can store those schemas as YAML files, so it means that we can pass them to other teams to define whatever needs the data needs to have. We can use some decorators to validate functions. So for the same data frame of before, we can say, okay, this function will have as input this data frame, and this data frame will be compliant to this input data schema. So we check the input, we check the output, and we know that this function will never return something that we don't want. And I think that this is very, very useful if you have some functions doing some data processing around. And that's it. So for example, one thing that commonly can happen with Pandas is that you add a column for some temporary computation, you forget to remove it, and then at the end you're just moving gigabytes of stuff around without any reason. In this way, this is avoided. So conclusion, I find Pandera a handy tool to improve robustness of data pipelines. And I hope that you have found this talk interesting. If you have any questions, please do.
Nice. Are you using this in testing too?
Not yet, but you could. I mean, we are implicitly using it in testing because it's embedded in the code, but not for only for tests.